you that the deadliest weapons of our time were inspired by machines made of wood, rope, and stone. Sounds impossible, right? But the truth is, the tanks that roll across deserts, the rockets that level enemy bunkers, and even the drones that hover above battlefields all owe something to the siege engines of the past. Before there were missiles and jet fighters, there were giant wooden monsters that could crush walls and hurl stones the size of cars. Imagine standing on a battlefield 2,000 years ago. You see a massive wall protecting a city. Behind you, engineers and soldiers are building something huge. It creaks, it groans, and when it fires, the ground shakes. That was the sound of ancient power, the kind that decided who ruled kingdoms and who lost them. These were the first weapons of mass destruction. Siege warfare wasn't just about strength. It was about patience, brains, and timing. When soldiers couldn't break through city gates, they had to think smarter. That's how the first siege engines were born, out of desperation and genius. They turned simple tools into terrifying machines that could break anything built by human hands. And every empire, from Babylon to Rome, used them to expand their reach. You see, war has always been a battle between defense and offense. For every strong wall, someone built a stronger weapon to destroy it. This arms race started long before modern technology. It began with the first city walls thousands of years ago. Every time one side built higher walls, the other side built bigger siege engines. That never-ending contest shaped the course of human history. But here's where it gets even more interesting. The ideas behind those old wooden machines never died. They evolved. The same physics that made a Trebuchet hurl stones now power our artillery shells. The same thinking that made a battering ram break gates inspired the modern tank. And the coordination once needed to build siege towers is now used in military robotics and urban assault planning. So yes, the ghosts of ancient engineers are still with us. Their inventions echo in the steel, fire, and code of today's warfare. What once rolled on wooden wheels now roars on treads of armor. What once launched rocks now launches precision-guided missiles. The tools changed, but the purpose to overcome barriers stayed exactly the same. And if you stay till the end of this video, I'll show you something surprising, how one medieval weapon, built from wood and rope, secretly inspired one of the most advanced and feared modern weapons ever made. You don't want to miss that connection. Thousands of years ago, before tanks and bombs, wars were fought with walls and ladders. Cities were strongholds, built to last. Stone towers rose high, and gates were made of iron and oak. For an army, taking such a city wasn't easy. Charging straight in meant certain death. So soldiers had to learn a new skill, the art of the siege. A siege wasn't about speed. It was about time, pressure, and fear. Armies surrounded a city, cutting off food and water. Inside, people waited, hoping help would come. Outside, soldiers worked day and night, building strange machines. The first siege engines, These machines were designed to do one thing: break through what humans thought could never be broken. The earliest sieges go back more than 4,000 years. Take the famous Siege of Jericho, one of the oldest stories in history. The city's walls were said to be so strong that no army could breach them. Yet, through strategy and persistence, those walls fell, marking one of the first recorded victories in siege warfare. Another early example, the Siege of Troy, though part legend, showed the same lesson: when force fails, cleverness wins. The Greeks couldn't break Troy's walls, so they tricked their way in with the Trojan horse, proof that siege warfare was as much about the mind as the muscle. Over time, these lessons turned into science. Armies began building devices that used physics, weight, motion, tension to do the work of 100 men. The first battering rams appeared in ancient Mesopotamia. Long poles tipped with iron heads swung to smash through gates. The Assyrians built them first, covering them with shields to protect from arrows. With every war, the machines grew bigger, smarter, and deadlier. Then came the catapult. Simple but powerful, it used twisted ropes and tension to launch stones or flaming balls over walls. It was the first time humans used stored energy as a weapon. Every launch was a lesson in math: angle, weight, distance. Behind each shot stood engineers, not just warriors. The catapult showed that brains could be as deadly as bronze. By the time of the Greeks and Romans, siege warfare had become an art form. They didn't just fight, they engineered their victories. Soldiers carried tools, not just swords. Builders, architects, and mathematicians joined the battlefield. Every siege became a test of technology, and this was just the beginning. The ancient world had learned how to turn ideas into weapons, and soon that knowledge would explode literally into one of the greatest ages of military engineering the world had ever seen. In the next part, we'll see how the Greeks and Romans took siege engines to a new level, building machines so powerful that even modern engineers would be impressed. The Greeks were the first to turn war into engineering. They didn't just fight with courage, they fought with ideas. Their cities were centers of science and invention, and when war came, that knowledge went to the battlefield. They studied how things moved, how weight and tension worked, and how power could be stored and released. From that came the first true siege machines, precise, reliable, and terrifying. One of the greatest minds of that era was Archimedes of Syracuse. He wasn't a soldier, he was a mathematician. But when his city was attacked by the Romans, he used his genius to defend it. He built catapults that could launch stones with deadly accuracy. He even designed giant cranes, called claws of Archimedes, that could lift enemy ships from the water and smash them. Imagine that an ancient scientist using math to stop one of the most powerful armies in history. His work proved that intelligence could be just as dangerous as any weapon. The Greeks also developed the ballista, a weapon that looked like a giant crossbow. It fired heavy bolts or stones with such force that it could pierce armor and shatter wooden gates. Unlike earlier siege weapons, the ballista was about precision, not chaos. It could aim, it could target. And in that way, it was the ancient ancestor of the modern sniper rifle or anti-tank gun. Then came the Romans, masters of improvement. The Romans didn't invent many new siege weapons, but they perfected the ones they borrowed. They made them stronger, faster, and easier to move. They built massive onagers, catapult-like machines that hurled huge stones over city walls. They used battering rams covered with iron and fireproof hides, and they built mobile towers. Tall, wheeled structures that could be rolled right up to enemy walls, letting soldiers climb over. But what made the Romans truly dangerous wasn't just their machines, it was their organization. They treated war like a construction project. They measured distances, built camps, and planned everything with military precision. Their engineers were soldiers with blueprints. Every siege was like a giant machine itself, with moving parts, men, tools, and time all working together. These ancient innovations set the stage for everything that came after. The Greeks gave the world invention. The Romans gave it efficiency. Together, they created the blueprint for future warfare, combining intelligence, engineering, and brute strength into one unstoppable force. And while their machines were made of wood and bronze, the principles behind them, force, leverage, tension, and trajectory, are the same ones that power modern artillery, tanks, and missile systems today. The technology has changed, but the math hasn't. The goal is still the same: destroy what stands in your way. In the next part, we move into the Middle Ages, a time when siege warfare became grand, brutal, and beautiful. This was the age of castles, knights, and the greatest siege weapon ever built, the trebuchet. The Middle Ages brought a new kind of war. Castles ruled the land, massive stone fortresses that seemed untouchable. Thick walls, deep moats, and towering gates turned cities into strongholds. For attackers, this was a nightmare. Traditional catapults and rams were no longer enough. Armies needed something bigger, stronger, and smarter. And from that challenge came one of the greatest inventions in history, the trebuchet. The trebuchet was a masterpiece of physics. It didn't rely on twisted ropes like a catapult. Instead, it used a giant counterweight, sometimes thousands of pounds, to hurl projectiles over incredible distances. When released, gravity pulled the counterweight down, swinging the throwing arm up and launching the missile. It was smooth, powerful, and deadly accurate. Some could throw stones weighing hundreds of pounds over 100 meters. Building one wasn't easy. It took teams of engineers, carpenters, and soldiers working together. But when finished, it was unstoppable. During the siege of Stirling Castle in Scotland, King Edward I built a massive trebuchet named Warwolf. It was so huge that it took months to assemble, and when it was finally ready, the defenders surrendered rather than face it. Edward refused their surrender. He wanted to see the machine fire. And when it did, it destroyed part of the castle wall with a single shot. The Trebuchet wasn't just about power, it was about understanding nature. It showed that with the right balance of weight, angle, and motion, humans could control massive forces. In a way, it was an early study of what would become modern physics and engineering. The same principles that made a trebuchet work, energy storage, release, and trajectory, are still used in rocket launchers, cannons, and even aircraft catapults today. And it wasn't only rocks that flew. Trebuchets hurled flaming barrels, diseased animal carcasses, even messages. They were early examples of long-range warfare and psychological attack. Imagine seeing one of those giants on the horizon, its arm rising slowly before releasing destruction into the sky. It must have felt like facing the hand of a god. Other siege engines of the time added to the terror. Siege towers, massive, moving wooden structures, allowed soldiers to climb straight onto enemy walls. Battering rams, covered with animal hides to resist fire, smashed through gates. Mangonels and springald launched smaller missiles for quick attacks. Each machine had its role, each one designed to break the unbreakable. The Middle Ages turned siegecraft into both science and art. Every castle wall had an answer waiting in the enemy's camp. Every defense inspired a new attack. It was a game of invention, one side building, the other breaking. And though these machines were made from wood and rope, they were the height of technology for their time. But the world was about to change forever. A single discovery would end the reign of wooden war machines. When the power of gunpowder entered the battlefield, the age of the trebuchet came to a fiery end. In the next section, we'll see how the invention of gunpowder transformed siege warfare and how that moment reshaped the future of every weapon that came after it. Gunpowder changed everything. For thousands of years, humans had used muscle, wind, and gravity to fight their battles. But when fire met metal, the entire balance of war shifted. The old wooden siege engines, trebuchets, rams, and towers suddenly became obsolete. Now, destruction came from explosions, not tension and weight. Walls that had stood for centuries could crumble in minutes. The age of gunpowder had begun. The first cannons appeared in China during the 13th century. They were small and unreliable at first, more frightening than effective. But the idea was revolutionary, using fire and pressure to launch a projectile, faster than any machine of wood and rope ever could. When this technology spread to the Middle East and Europe, it sparked a military revolution. By the 14th and 15th centuries, cannons had become the ultimate siege weapon. No longer did armies need to build massive towers or wait weeks to break through walls. A few well-aimed cannonballs could do the job in hours. Castles that had once symbolized safety became death traps. Their tall, proud walls actually made them easier targets. That's when architects and engineers had to rethink everything. The tall medieval castles gave way to star forts, lower, thicker, and angled walls designed to deflect cannon fire. These new designs showed that war was always a game of adaptation. When one side invented something new, the other side evolved to survive it. Cannons kept growing stronger and more precise. Bronze barrels turned into iron. Gunpowder mixtures improved. Armies learned how to transport and reload faster. Soon, siege battles weren't just about knocking down walls, they became about who could control firepower. By the 17th century, famous engineers like Vauban in France had turned siege warfare into a science. He designed complex attack systems, zigzag trenches, artillery placements, and timed bombardments. Instead of building siege towers, armies now built earthworks and artillery lines. A good siege was no longer about brute force. It was about precision, planning, and patience. In a strange way, the spirit of the old siege engineers lived on. The same problem remained: how to get past defenses that were designed to stop you. The weapons were new, but the goal was ancient. The cannon was simply a metal trebuchet powered by fire instead of gravity. And from that moment on, the arms race between defense and offense accelerated faster than ever. The 19th century brought rifled artillery, explosives, and mortar. Then came tanks, rockets, and bombs, all descendants of those early cannons that first shattered castle walls. The Gunpowder Age didn't just end the era of stone fortresses. It changed how humans thought about war itself. Power was no longer limited by strength or size. It came from chemistry, pressure, and precision. The siege engines